Today we're going to talk about scaling SQL Server, and that's something that I think everybody in here has an opportunity to do, whether or not it's for a unique peak workload, whether it's Black Friday, Cyber Monday, et cetera, / every one of you probably already has, I call them revenue generating transactional servers that you need to scale every single week, every single day of your life. A little bit about me. I've been consulting for like 25 years, mostly around SQL Server. A lot of times I get involved with, I call them high-risk, high-transactional environments, helping clients design those architectures to be able to support those revenue-generating workloads. And through a lot of those experiences, I've gained different knowledge to see what works and what doesn't, and those are some of the things that we're going to talk about today. The other passion I have, and I'm from the US, North Carolina, where barbecue, smoking out was sort of the first time in America. I'm a barbecue judge as well. So that's my other passion that SQL Server helps pay for. So today we're going to talk a little bit about what are some of the goals that we want to accomplish before we just go scale system, buy hardware, implement availability groups, whatever the tools and techniques are. We need to understand what we're trying to accomplish. Are we trying to scale the system to meet a certain transactional volume or a certain performance SLAs, et cetera? Second, we're going to talk about the workload. So we all defined, if I asked you guys, everybody today, what and how do we define workload, we'll probably have a lot of different answers, right? Some people will go, I go into SQL tool number 1, and I look and say, here's my workload. Some people will go and say, I remote into a desktop and I see my CPU and so forth. That's another view of the workload. But what we want to do is define sort of what way do we look at the workload, and then how do we use that information to be able to create the options to scale our systems. And then we're going to end up with creating a plan. So we're going to find out that what I do first, second, and third really dictates on how fast I could accomplish my goal. So we're going to start off with what is scaling a database? What does that actually mean? Right? When you think about that statement, how would we answer that? A lot of times we always just think, let's process more. But when we look at a unique situation, a lot of times we get a call from a potential client and they say, hey, Fortified, we need you to help us scale a system. And there's a large .com. They had a data center in Boston, they had a data center in Seattle, and they were growing very significantly. And they said, hey, we need you to help us advise us on how to scale our systems, while at the same time we're implementing a new data center in Ireland, and we need to be able to be fully redundant across the 3, but that's a separate topic. But we also need to scale to meet this great revenue growth that they were seeing. So they just said, we want to scale 10x. 10x is a big number. And they were just talking about data centers and so forth. Which SQL Server do we need to scale, or SQL Servers? What does that mean? So we had to work with them on defining what that 10x actually meant, over what time period, because we don't, and a lot of times that does not happen overnight unless you send out a big Super Bowl campaign. So when you think about defining what transactions actually mean, is it executing more? A lot of times I think about, how many transactions can I process, right? But what about, can I do those faster? So a lot of times we also tune our system to be able to accomplish more things more quickly. Or if I reduce resources, a lot of us, how many people in here do performance tuning as part of their daily or weekly job? A couple people, right? So that could be part of scaling, because what are you doing? You're creating excess capacity or more freed up resources to be able to process more transactions potentially, right? Or you're making that system be able to process those transactions more quickly. The other way you could look at it is, what's the weakest part of my system? So when I scale a system, I'm not only looking at top-line transactional throughput, I'm also looking at the weakest links, because I could have all the redundant hardware, I could have all the redundant copies of my database, but my weakest part of the system will probably take me down. And that outage is still an outage. So when we think about what we will have to think about, we need to think about also the weakest part of the system, and how do we identify those? A lot of times it's optimizing those weakest part of the systems as well. And the final thing that we all also have to ask is, are all transactions the same? No, they're not. There are certain ones, and a lot of times, I'll give you another example. We got a call on a client that was out west, and they said, hey, we got to scale tomorrow to have about 160,000 people log on, and they usually log on in the last half of the day, and they need to process it, and they're running on Amazon's largest SQL or IaaS instance, which is 128 cores. And said we can't take the system down, and you need to do some magic to be able to get our system stable because no one's been listening to us, but now we're allowed to call you. So when we got on the system, we had to make a choice because I said, you are having what I call scheduler pressure or CPU pressure, okay? So the number of concurrent processes coming in couldn't process the workload. The other thing is they also had all these reports being generated and run, and they also had revenue generating transactions. Which one would we rather process? Probably the transactions that make us money, right? So I got buy-off from them. I said, okay, if we want to make money, these are the transactions. And we changed some settings to throttle the reports. So I said, let's have reports run a little bit longer and also not use as many threads when they run, worker threads and so forth. That allowed them to process all their workload for the first time in months because we prioritized the type of transactions as well. There I was just I'd say integrating some business knowledge and expertise with transactional or system knowledge as well. So we went and talked to the business and said, hey, you got a choice here. What are your opinions on that so that we could all accomplish the highest priority goals? And then you think about, a lot of times the business generates a lot of this because they're running campaigns, right? They're adding new features and modules. So we want to understand how much are they going to grow, and then at the same time is if they implement a feature, what does that really mean in the database? Is it going to add, a couple megs per week or a couple gigs per week? And I've seen features that add potentially terabytes over a month because they added some blobs in row in the database, and it's also used very significantly. So we want to understand what are the features they're adding, what type of data impact that has on the data growth. So we've been talking about transactionals. The other way we also need to think about a system is data growth. So transactional is a volume metric, what I call a volume metric. Data growth is another volume metric. Those are things that we're sending to the server. Once we start to have this data, now we get to understand a little bit around what and how does it relate back to business functions. And the last one is really, what is the performance expectations of that business? So we have clients that are healthcare that have 1 or 2 second timeouts. We have trading systems that need to be executed in 250 milliseconds, right? So if I'm processing 10,000 transactions per second, we might all clap our hands, go, we actually have their roles. But if they're processing at 5 seconds and I need them all done in 2 seconds, I didn't hit my goal. So a lot of times there is a performance constraint or requirement along with a volume metric or objective as well. And I will be doing questions later on. So if you do have questions, just raise your hand as we go through this as well. So we're talking a little bit about volume metrics. So what do I look at when I look at a system? So there's really a couple different things. Up there you see data growth and volumes. So this is how much is my data growing year over year, month over month, right? How many people know what their data growth was last year for, I call it your most important system that you guys support? A couple people, right? And can you guys share, like, was it 10%, 20%, or 100%? What are some of the 15 to 20? About 15%? Yeah. So I'm seeing a lot of 20%. And think about this, if that system was created 10 or 15 years ago, because a lot of these platforms that we're supporting were developed 10 to 15 years ago, 20% year over year. Now these systems are getting big, right? And we need to think about what that impact is on my data buffers, memory footprint, right? Or my I/O throughput or my volume sizes, right? The other one is transactions or batch requests per second. So we look at it 2 different ways. So batches are one or more transaction or one or more requests packaged together. That's a batch. Okay. Then transactions are some DML activity, insert, update, delete that hits the system. If I'm an analytical system, my batches are potentially very low, right? But I also, depending on TempDB and all this other stuff, I might have very high transactional volumes because I might be spilling a lot to temp. So we need to pay attention to both transactions per second and batch requests per second. I'm going to show you where we get a lot of this data in a second. We also want to understand resource volumes. So if I'm requesting and running 10,000 requests of all different types of code, those have an impact. The impact is I need these 4 resources to execute my code, right? Depending on how that's optimized, my data footprint, the volume of the code, the mix of the code, they will yield different CPU, storage, memory, and bandwidth requirements at any single point in time. And what we want to be able to do is track these over time. So, and are you guys tracking that in a system over time where you could easily query it, right? So you could see this, the data changes, the data growth rates, right? So I've done some simple things where DMOS performance counters in SQL, I just dump some of these metrics to SQL, and I've had clients that have been running that around 20 years, and you could easily query it, put it into Excel. It's amazing what that looks like, and it's very, very simple. So you don't need to be running perfmon, and a lot of the performance tools that are out there aggregate that up, and it's very hard to get this truly trended over time. So I use native SQL, dump it to a table, and just query the DMOS performance counters, and that way I could track it over years or even decades potentially. The last thing I want to mention is this. Whenever you do have a peak workload, and we're going to talk about the win and some of these other things, we need to figure out a way to tag it, right? Because if you see this peak and go, wow, this was today's busiest day, I need the fast, quick, easy way to go back to that data last year. So every year, there's clients that call us and say, hey, by the way, Ben, we need to scale again. Can you take a look at our system? Instead of going in and going to the file cabinet and trying to look at all this stuff, we just basically pull out a thing that's tagged peak per se, and I now can say, okay, well, last year, you guys did these metrics. Ask those business questions. Let's forecast what you're going to do this year. We make it simple. So what we want to do is, I'm going to show you a couple things that we need to think about when we're scaling a system. So one of the first things is, can you guys see this? We need to get a little bit of understanding around the configuration and around what are we doing today, right? So this is MS Info 32, and it's on every single Windows system, and it dumps a lot of great information, and you'll have the OS version in there. The thing that I like in here is this type of information, okay? I'm going to briefly talk about why this is important. I have 2 versions of this. One is actually, I call it slow CPUs. I care about a lot of this data because I have the memory footprint right below, but the piece of data that I really like later on when I'm sizing, and we'll get into this in the scaling section and creating the plan, is I look at these numbers. So there's a certain processor, and that processor can run a certain speed, right? It could perform a certain set of or number of instructions per time interval, right? This is a 2 gigahertz, okay? If I go over to this one, this is 3.1. The generation of the processor, you always hear the Moore's Law, doubles every so often. It comes into play very important when you're scaling systems and running MPP or massively parallel processing applications like SQL Server. This will determine how many instructions I could run per second. It also helps reduce your licensing costs. This is one of the easiest ways to reduce your licensing costs. If you find the right platform, you can end up doing 2 or 3x the number of transactions per second with fewer number of CPUs. So down here, there's information about the memory and so forth, right? So we want to look at all this, and at the end of the day and I'm going to have this available. So these are some of the volume metric counters we look at. And if you look up here, we see logical disk. So this is all out performance monitor, which is also a native tool inside of Windows. But you also see process, SQL Server, I/O data bytes. So I always still validate that even if I'm looking at the logical and all these throughput, I'm going to look at the SQL Server metrics as well to validate that SQL Server is the application that's generating that workload. And then we also have bandwidth, we have memory, and SQL Server. So down here, you have those transactions per second. Now that's total. I will also capture for every database that's in the system, because I want to know that your critical database is using this, and then I also want to know what TempDB is using at the same time. So when you think about the time, and defining the workload, when is your workload? How many people know when their peak workload is, right? A lot of us have a pretty good idea. But what's interesting, when you start to look and log a lot of this data, a lot of times there's some surprises in there. We did a large project for a very large insurance company. What was interesting about it was this. We captured some data across 1,400 SQL servers and said, what's your average utilization between 8 and 6 p.m., 8 a.m. and 6 p.m.? It's around 5-point-something%. We did 24 hours. CPU was higher, like 6-something%. So at night, a lot of times we actually press these servers harder than during the day for most business applications. So not all the time do we actually know when we're actually doing the most transactions or the most work. A lot of times our maintenance processes, our batch processes, import processes do a lot more work than our core transactional, right? So then that is when we also need to understand what are we going to tune. So if you do have that data in a database, you can then pivot it and use Power BI and so forth to look at it by month, by week, by day, by hour. So how many people know the busiest day of the week for their workload? Just raise a hand. Couple people. Do you guys know the busiest hour of the day, right? When is the most people in your system? And getting this information helps you plan, because sometimes it's also just adjusting schedules within your system. When do you do stuff? There's a lot of things that are very easy to move around, right? So how do we define and measure a database workload? So it's really, to me, 6 different components. First thing is time. Every single second in your day in that system technically can be looked at and has a unique workload, okay? Now, a lot of time within a system, those seconds can all be grouped together within periods of time, and you're going to see similar behaviors, similar code patterns, right? Similar resource constraints, similar usage, volume metrics, etc., right? So all the code that's executed at any point in time is going to use a certain number of resources, right? And it's also going to end up having a certain number of transactions. So maybe between 12 and 1 p.m. when everybody's on lunch, but maybe your application has the highest usage of them. I can expect 1,000 transactions on average per second during that period of time, okay? That's the volume metric. Now, when I look at the time, look at the volume metrics, and then they request and run execute code, right? They're going to go against the schema and the footprint that impacts how many resources do I do. So if I have very flat, wide, denormalized tables, and I execute a lot of code against that, I'm going to have a larger I/O footprint. I'm going to potentially be flushing memory a little bit more because I have these large records I need to read into memory, which is going to push other data out, right? That is determined by your schema. That's determined by the type of code that you write. And then, how is it optimized? And at the end of the day is, what is the impact on the resources? Do I have and put stress on my disk? Is my disk response times actually healthy, right? What's my bandwidth? All these together, I look at it and say, this is my workload. And the way we're going to look at it in just a second is, it's a lot more simple because we break it down into 3 different ways. And I just call this the workload RX. So if I go look at any of your systems today, I'm going to do a couple different things. There's a piece of code I open up and I run that maybe 10 times. I might run it now, wait an hour, run it again. And I mentally look at a couple different things, right? But that's going to show me point in time. How do I know how healthy every one of your systems is, roughly, in 5 seconds or less. Wouldn't that be cool to know? So there's a way. Has anybody ever seen or used this data? This is out of Perfmon. It's called batch response statistics. Does anybody ever use this before or seen it before? Okay. So what's interesting is this. This SQL Server tracks every single batch request that comes into the system and bucketizes it into one of these buckets. And there's two different types of data. One is based upon CPU time. Another one is elapsed time. So if I go look at a system and I pull this and I just open up Perfmon, this data is going to pop up. I don't even need to capture for 7 days. It's already aggregated. It's like a DMV, constantly aggregating until I next restart. I could pop this up, and what I'm going to do is this. This is the way you look at it. We want it, if your transactional system, you want it to be a waterfall. You want it to be your highest calls on top, waterfall down, okay? The next thing you want to do, and I have some just high-level, I call it Ben rules that I follow when I'm tuning and optimizing systems. Probably should have a better name for that, right? The Ben rules. Is the top 3 requests should be around 98% or more of all requests. And you might go, well, my system's not optimized that much. It's slower hardware. You'll be surprised by how much code does execute very, very quickly. Think about all the lookup tables, all the small queries. A lot of those will execute very, very quickly. So one thing I'd ask after this session, and you get back to your office next week, and you get back in there, maybe open up Perfmon on your server, pull this up, just see where you're at. See how well does it look like a waterfall. And then this bottom one, you can see it goes down and then out a little bit, then down. So those are the things that we want to then try to optimize. Because this helps us understand where do we need to tune and optimize. So if I go look at top SQL, what does top SQL mean to me? Stack, rank, top, I aggregate. Yeah, I could tune that. But this is showing me exactly where in my system I need to optimize. So in here, on this top one, it's 50 to 100 milliseconds. It's really 50 to 500 milliseconds. If I tune those calls, and let's just say I'm having CPU time or CPU pressure. So you said, wow, we're having our bottleneck CPU. Where are you going to tune? If you tune that, you could save, potentially about 1.5 billion CPU cycles. You're not going to get all that away, but that's where you start to filter your top SQL too, and you're going to be a lot more on the mark when you actually tune that. Over here is the lapse time, so you can start to see where you're lapsed. And what we do is we have some technology inside that allows us to sort of stack rank this. I always like, this past view is great, but there's no percentages. How do I know if my team is moving the needle up and progressing? So the great thing about this data is too, whether or not you've upgraded hardware, changed configurations, tuned code, added new features, scale out, increased workload, added indexes, I could look at this. You could start to measure success by this too. So as you tune and you add 10 indexes, how do you usually show your impact or your progress to your boss? You set statistics profile on, time on, IO on. You capture the data, copy to Notepad. You do before and after. You go to your boss and say, boss, I tuned a piece of code. It's awesome. But that index is probably used by a lot of other code, especially if it's on a critical table that's mainline. This way, you could start to show the boss the true impact of that index change, not the index change just for that piece of code. So what you do is you look like this. And I also then sort this. So you could dump this into Excel, and you could sort this. So I could look at this batches by request or batches by time. Where I tune is batches by time, right? So I can know that if I go tune that top, which is greater than 100,000 milliseconds, 19%. Now this is for an optimal system. This is a large .com, and we've tuned this. When we first met them, it was very interesting because they were not 98% or 99%. They are more around 95%. In the first month, we did some tuning. We got them up to 98%. We showed them one picture, before and after, and they were sold. They've been working with us every year since. This is a non-optimal. This is another transactional system we're about ready to engage on. right? So we're assessing their environment next month. Guess what? We get to show them. We're going to show them that they're not optimal, right? Very clear, 83%. Where do we want to take them? 98%, right? How do we get them there? We're going to talk about that in a minute. But where do we tune? Here's where we tune. These are very simple ways, because what I want to be able to do is measure any system in this room the same way. If I just look at CPU and exec requests, it's hard. Everybody has a unique footprint, fingerprint, etc., right? This helps us even it out and look at definitive metrics no matter what system and where it's at and what host it's installed on. Now we're going to talk about SQL Server workload. So a second ago I mentioned if I go into your environment, one of the first things I'm going to do is I'm going to run pieces of code, DM exec requests, and I join it with some other stuff. It's sort of like SP Who2 is active on steroids, right? I've been running it for ever since 2005 came out. It allows me to really see the personality of every person in here / system in here. And the things I look for, right, and I've been doing this a while, so I sort of photograph this every time and snapshot it. I'm looking at long resource waits. So you have the resource columns there. Do I have resource waits? What are my average wait times? What are the resource waits on? Do I have database contention? Is this when I was driving in from London, right? You hit these traffic jams because everything's single lane road, right? Those are, the blocking chains. Do we have blocking? Congestion in the system. Who is calling me, right? What are the applications, right? What are the logins? What are the code that they're executing? I start to become familiar with this. So your most critical system, you get to need to know that very well. And at the end of the day, what are the average run times? So very, very quick systems, you will not see many results if you do exec requests. Exec request returns records that are running and active in the system that are running a little bit longer than a couple milliseconds. Because do you ever run SP2 as active and get 10,000 statements back if you have 10,000 batch requests per second running? No. You get a handful. And those are the things that are running a little bit longer, okay? So this image down below is sort of like just a screenshot. And what I can do after this session as well, is give you some of these batch perf mon counters, the code that we like to run. If you email me, I'll be able to send that to you and so forth, okay? And what we do is we want to run these pieces of code over time, different times during the day, so that we understand what are my personalities. Because I can guarantee you 12 o'clock at night is different than 12 o'clock at the day. You're going to be running batch processes, your maintenance processes, versus taking transactions. And I'll show you a little bit around the workload. So when we look at the workload, we look at it a couple different ways. Now, we have a utility that allows us to dump any code we want or that we run into Excel, and then we have different worksheets. One of the first things I always like to do is say, who's talking to me? How many app servers, web servers do they have? How many other SQL servers are connecting? What are my number of connections coming in? So this is a smaller environment, so you can see the total connections is maybe 20 or 30 per connection. But large.coms might have 800 of these. Things I look for in this are the patterns. If I'm a web server, I should be roughly the same number of connections. Do I have any really high ones? Sometimes they have one that's like 300 connections. And we just want to become more familiar with that. When we look at resource usage, how many people have a database that might not be as critical as your critical database on the main server? A lot of times we have the database that runs the program, but what we overlook sometimes is the logging databases, the non-critical databases. We end up having those on the same server. If you're really going to scale, sort of like Formula One, they look at every single piece of data around the wind and everything else. So if we're scaling a system, we want to be aware of all of our opportunities that we have to potentially free up resources that will allow those resources to be used for a better cause, meaning the revenue generating transactions. So here you can see I have a logging database on here. It's 28% of the CPU. An easy move would be, let's log that database somewhere, move that database somewhere else. And guess what? I free up potentially 28% along with 24% of the I/O and 26% of the memory. A real-world story is a large ebook company called us, and they said, hey, and this was about 10 years ago, they had a 100 terabyte plus transactional database, a single SQL Server. And this is about 10 years ago, right? They said, hey, we need you to assess our environment. So we go in there, and there's a lot of unique things that were non-optimal in the hardware and so forth with what slots and everything. But the unique thing was, I was like, what's this database in here? It's using 30% of similar to this. They were logging back. And when they logged, they also logged, and then after the transaction, they came back and did an update. So I had two issues there. One is resource constraint. The other one is database contention. And then I'm having my lock manager manage more because I have all this locking blocking because I have all this insert volume stuff with my update. They changed it so that they only persisted the data once, and they waited to get that so you didn't have to do an update. So I reduced my transactional volume right there, right? And then I moved that off. I gained 30% and reduced contention on the system by addressing that. So always run a simple query like this where CPU, I/O, and memory usage, and I could give you these queries as well, and it will allow you to see what is everybody using. Sometimes it is not what you expected. The other way I use this is as well, if 99% of my code is running in 1 millisecond or less, none of these tools, even you do not want to run extended events to capture the code. How do you know when you have planned regression on a 1 millisecond query that goes to 10 milliseconds that runs very frequently? You're not going to see it in a tool. What's easy way to see it? You see it in this. So the other thing I run, because I won't see it in my exec requests, I won't see it in a tool, see it by this. So that large.com that we tuned a couple years ago is interesting. They had a plan go bad in a database. And I knew they had two critical databases on their main system. One would use 99% of all compute and resources. The other one would use 1%. One morning, they had a couple calls come in, and they said, we have an issue. And we said, I ran this. That other database was 5%. The main one was 95%. I knew that they had planned regression in that other auxiliary database because that compute, it all sums up, and you could see it shift in here. Then we started looking inside of there to be able to say where and what. So one of the other things is resource view, right? So when we think about the resource view, is down on the left, that's perfmon art. I sell that for only 100 pounds per signed subscription. But I leverage perfmon for the longest time, and I ninja through that. But what we want to be able to do is, this is another way to look at the workload. And we want to understand that workload to understand when are we doing the most work, how healthy are we, how much chaos or friction do we have, right? And are we stable? Do we see similar patterns? Are we a repeat pattern? Are we ad hoc, right? So on the right-hand side, we always send a data collector template to a client and say, this will run for 7 days, 5-minute captures. It's like looking at task managers. Not going to have any impact on your system. It'll capture around 800 megabytes, compresses down to around 20 megabytes zipped. We capture that. And this allows us to say, okay, yes, I looked at your batch response statistics. I sort of know how healthy you are, right? I ran and say, I know what code you guys have. Now this shows me how many resources I use when I execute it and when I have the pressure, right? So in here, we're going to look at it a little bit, or a couple of different examples. There's some good noise everywhere. Let's see. Okay. Did you guys know you guys have a test today? We have a test. I don't like tests, but no one could get anything wrong. But we want to understand, these are two images. If you collect that and you just double click and you open it, you get an image like this, okay? Two images, 7-day captures, 5-minute samples. When we look at these two images, same number of lines. One might look like it has more lines, same number of lines. We always say, if I'm going to scale a system, what do I need to be? I need to be highly available. Yeah, I implement availability groups, right? What else do we say? I need to be stable. I need to be predictable. Because even if I have something bad that's happening that's predictable, I can sort of plan around it, right? So if I'm stable and predictable, how do we measure that in here? Any ideas? Which one do you think is more stable? So one on the left or one on the right? So if you guys think the one on the left is more stable and predictable, raise your hand. Okay, half. People on the right, or graph on the right. Okay, so about 2/3, 1/3, okay? So the one on the left is more stable, and this is without knowing the lines. Now, we still have what I call chaos in here. So if I go look inside of here, and if we look in here, see that red line I just drew? It's interesting. You know in a symphony, when the symphony warms up, the conductor raises their arms, and they all start playing music, and it's all different notes. What happens? Then they come together, and all of a sudden they're playing one note, right? It's harmony. So in here, that's sort of like chaos, and everybody's playing their notes. Very frequently, those lines represent issues within your system. I call them friction, okay? We don't want to schedule and run processes around it, and we do want to research it to understand it to probably address it. So when I'm looking at another workload inside of here, right, I'll just make this bigger. This is nice and smooth every single business day, and this is probably similar with many of your apps. I come in, go up, go down. This is very easy to say, when do I schedule processes? How much capacity do I have, right, if we look at individual counters. What's tough is when you get an image like this, there's a lot more noise. So the question I have for you today is this. Let me get back in this. This is an important question. What are the changes that you would make if you popped up that graph? What are the changes you'd make today to help that graph get better tomorrow? It's tough. I just showed you a whole bunch of crazy lines on a chart. How does that relate back to a SQL Server configuration, a piece of code, an index? And we'll talk a little bit about that. Because that's essentially what we have to do, right? So one of the things that we want to be able to do is create a plan. Now, we don't have enough time to talk around all these different options, right? So this is where I'm going to give you some guidance. And the order of these is the order that I and my team follows and implements these changes at any client. Because we always want to start with the least risk, the least effort, the easiest changes to make first. We don't want to jump in and say, hey, you need to refactor your transactions table. That's going to be a lot of work. The client's going to get scared. You're going to say it's cost a lot of money, it's highly risky, and will it yield the benefit? I don't know. So we want to start on the left-hand side. So we want to start with the configuration. You could get a lot of wins by just the configuration. How many of you configure all your SQL servers to be the same config because you have a good base config, right? A lot of times we might have a lot of our servers be configured the same. Is that ideal for certain SP configure values? Probably not if you're doing analytical workloads, secondary read-only workloads, and transactional workloads, prod and non-prod. Lots of different variables in there. We want to understand that workload and then configure the servers for those type of workloads. So a lot of times we'll have configurations based upon the workload, not just prod, non-prod. Because ultimately that's going to allow that server to perform better and be more optimal. And it starts at the host level. So in production systems, and if you need to ask around what this is, but in the BIOS, we turn C states off. We make sure high performance is on. We make sure that memory's also high performance as well. These are little things that make a difference, especially if you're above 10,000 transactions or 20,000 transactions per second, right? On the hypervisor, we also want to look at what are some of the things that we could take advantage of, because how many of you have a virtual environment that the virtual team configures your SQL servers just like every other server? Are they the same? a file server is a lot different than a database server. And I always say we need to design them for data-intensive workloads. I'm going to be pushing a large amount of data, especially if you've gone through a consolidation project. Guess what happens? You put a lot more databases on a smaller footprint, and then you stack them even more tightly in these pizza boxes on these racks. The aggregate performance or resources out of that stack is pretty high. So that's where just vMotioning some of these things around can get you a win. Remember I showed you the processor frequency? A lot of times in your virtual environments, they may have your server running on a certain, I call it processor type or host. If you're going to scale and you have some CPU challenges, it might be as simple as looking, saying, hey, virtual admin, are there any other servers that have a higher processor frequency or a later generation, right? And you could go to specint.com and be able to find, I call it the miles per gallon. They could vMotion, and overnight, you have that gain. So because of the time, these are the things that we go through up and down to be able to accomplish. But the areas I focus on the first is config. The areas that make the biggest impact is going to be indexing. It's going to be moving those logging databases around. It's going to be adjusting the schedules to be smart. So look at when you are processing the most, stagger your schedules. How many have you ever looked at how many jobs you're starting at any single point in time? Everybody's schedule's on the even. We're all humans, 0, 15, 30, 45, right? Those are simple changes. And then it's around rinse and repeat. We need to identify what we need, assess, right? And then we want to act, and then we want to validate or measure again. That's the only way that you're going to look at that perfmon on the right and get it to the left. It's iterative changes, right? Batch response statistics. You want to see those percentages go up the graph, go towards a waterfall. The thing that most people overlook is monitoring. So how do you know when something happens when you're having a system that is scaling and it's not running efficiently, right? Monitoring, right? Unless you guys get paid by the hour and work 24 hours a day and you're rolling it in, we probably want to leverage some monitoring. One of the challenges I see, a lot of people will not update their thresholds based upon the critical system versus the regular systems. The other one is we have too many dashboards. So think about the Datadogs and the Splunks or data observability tools, right? A lot of us have them. They're great at getting us information. What's the side effect? A lot of these organizations that we scale system for, they have 200 reports to tell us the health of a system. Well, which one of my reports is going to tell me the health of my system? And they're still interpretive. So I say design 1 to 3 dashboards that are very important for that server based upon that personality. And you should have everything on one page. Realistically, maybe 2. And the second thing is when something goes yellow to red, have a process for every single thing on that dashboard. If something here goes sideways, have a process. Don't go, oh, can we get Johnny to look into this problem and maybe research it? Seconds or minutes are a lot of money for a lot of these organizations, and those are the things that we need to solve to be able to solve quickly, to save the users negative feedback, etc. Right? And I know this was a lot in a little, but hopefully you guys got a little bit of tidbits out of this, and I'm going to open this for questions because I know I talk fast. So any questions? Yes? Correct. Yes. So good question. The question was, I thought this was going to be about a different topic around, hey, how do we scale up or how do we scale up in the cloud to be able to handle this process? At the end of the day is this. If you're measuring this and looking at the volume metrics, hardware is only going to get you about 75% gain potentially on the top side if you have any bottlenecks in your system today, okay? Scaling out, is one of the easier ways you could start to scale out, and that's going to benefit you from reducing the number of transactions that are processed on your core transactional server to go to secondary, and I could have multiple read-only secondaries, right? But the hardware will only get you so far. It's really around measuring and understanding what are the things inside of that container, no matter if it's in Azure, in a VM, or on-prem. And I could talk to you offline around if you have a specific scenario, because I only had 50 minutes to say measure and plan and so forth. Yes? Yes. Yeah. Yeah, so the question was, when you're looking at some of the patterns and so forth, can we leverage Query Store to get some of this information and leverage that to help optimize and tune? Absolutely. So when you think about the batch response statistics and saying what is not performing optimally, go leverage Query Store to say what code falls in that resource bucket, and then let's go start to optimize that, and then you could really start to get that feedback loop going. So Query Store is a great resource. I don't know if you guys have it enabled by default on a lot of your systems. Leverage that. Microsoft's investing a lot into that and making it a lot more intelligent so that plan regression kills systems. So we could have excess capacity. We could have secondaries. But if I have database contention or plan regression, it takes down systems. So, any other questions? The other thing is feedback. So, the way I get better is by you guys letting me know what I can do better. Feel free to contact me. My contact information's up there. If you do want a lot of this code, whether it's the perfmon data collector, the code that we run to export stuff, I give a lot of that away to anybody because we all want to grow and learn and solve tougher problems tomorrow. Hopefully you guys like this conversation. And if you guys have any questions, I'll be here and also around here outside. So thank you.